Okay, we're going to do another definite integral problem. And remember, you don't have to draw the graph to think about this, but it can help you make sense of your answer and think about whether your answer is reasonable or not. So I'm going to think about graphing the function f of x equals x times e to the x squared. Use your graphing calculator to help you with that if you want. So the thing I might notice about that is, first of all, when x is negative, the function values are negative. So the function is below the x-axis here. When x is positive, the function gets really big really fast. In fact, if you graph that in your standard viewing window, it'll go off the screen really fast here. So this graph is not to scale, but when x is -1, the function is below the x-axis. So the sum of these function values on this region would be negative. When x is bigger than 0, the function is really tall, really fast. So when I go over here to x equals 4, it's probably off your screen, but very tall, very fast, and a very big area of a region over here. So for this part, the definite integral will be negative. For this part, the definite integral will be positive and very big, because when I put in 4 to that function, I will have 4 times e to the 16, which is big, like millions, tens of millions. So it doesn't matter how big it is, it's very big. Right? So I'm going to add up some negative and some positive, but the positive is way going to outweigh the negative. And so I should expect to end up with a positive big answer. The other thing that maybe you think about is that this function is actually symmetric with respect to the origin. You can maybe see that on the graph, or you can prove that using some stuff from algebra. So there is a little part of this graph where you have a positive and a negative region that will cancel each other out or add up to 0. So I'm going to have, if I integrated from -1 to 1, I would expect to get 0 for that answer, because I'll add up some negative function outputs and some positive function outputs that would exactly balance each other out. All right, but I expect to get a very big positive answer because of what's happening after x equals 1 to x equals 4. I'm going to have a great big huge positive area of this region. Okay, this function is continuous, so we can use fundamental theorem of calculus, find an antiderivative, and evaluate at the endpoints. Thinking through this function and our basic antiderivative rules, you should say, I don't have antiderivative rule for this. I do for x, I do for e to the x, I do for x squared, but not product and composition of function in this way. All right, so if it's not a basic antiderivative that you know and you can't do algebra to force it to be, then it's a U-substitution problem. So you're going to think about letting u equal the inner function. If you can see an inner function here, I have an x squared function that's inside the exponential function. So that's what we're going to let u equal. My du is 2x dx. So I do have an x dx, but I don't have a 2. So I'm going to divide that over. I like to mark the problem up. So in place of the x dx that are separated from each other, but x dx that's here, I'm going to put in 1/2 du. In place of the x squared, I'm going to put in u. That accounts for all the variable parts of this problem. Remember that these limits of integration are x values, so if I'm converting to u's, I need to convert those as well. So when x is -1, u is -1 squared, which is 1. And when x is 4, u is 4 squared, or 16. Okay, so when I convert this, these limits of integration are going to convert to 1 and 16. All right, so I'm going to integrate from 1 to 16. In place of the x dx, I have 1/2 du. Pull my 1/2 out front. And then e to the u goes in place of the x squared. All right, now this is a pretty straightforward antiderivative. Antiderivative of e to the u is just e to the u. And then I'm going to be evaluating from 1 to 16. Put in the upper limit of integration first. Okay, e to the first is just e, so you could write your answer like that. You could factor out a 1/2 if you want. Beyond that, I don't know. I probably wouldn't simplify any more than that, so do this. Maybe put this into your calculator and get a decimal approximation. Again, I'm expecting a very big positive answer. So when you type this into your calculator, you get about 4 million and something. So that makes sense in terms of thinking about what the picture was. So makes sense, all right? And if I got a negative answer, I would know that that didn't make sense, thinking about the very big positive region that I have over here. All right, try some homework problems like these.